Morning, everyone, or afternoon if you are um, in the afternoon. I guess good day is the best greeting. I'm Monica Brain. I'm project specialist with Amerant Critical Infrastructure. Many of you are return visitors to our webinar, so I'll do my little song and dance quickly. Amerant Critical Infrastructure is inside the insurance company Amerant, and we are available to help with grant writing, project management, anything like that. You can contact me, mbrain@amerant.com, if you are interested. But I am pretty excited about our conversation today. Natua Garcia is with us. He is risk control consultant and from the Pueblo of Santa Ana. And Natua is going to talk to us about electricity. He's going to explain electricity? No. Natua, you're going to talk about how to be safe because May is Electrical Safety Month. So you're up on the screen and go ahead and take it away.
Perfect. Thank you, Monica. Appreciate it. Good afternoon, good morning, good day. Today, we are going to talk about electrical safety for the unqualified person. I know that kind of sounds a little bit scary, daunting, unqualified person. What does that mean? So, the unqualified person is workers who are not qualified to perform electrical work, but who need to know important information about the hazards of electricity and how to prevent serious injury. So, that's all of us who aren't electricians. So today, some of our objectives, we're going to understand the basics of electricity, describe the hazards of electricity, identify and avoid common electrical hazards, follow safe work practices around electrical equipment, and, lastly, seek assistance from a qualified person. Knowing when to call, sometimes you have to put the pride aside and say, hey, I don't know how to do this right now. And so as the training goes on, we'll talk about some different scenarios, some examples. I might go off on a tangent, talking about why it's really important we check our electrical cords, electrical connections, not just flip switches and hope for the best. So we'll start off, how does electricity work? Okay. So we have to understand, the basics of electricity. Electricity is the flow of electrons. Similar, we could think about it as similar to the flow of water in a pipe. We turn on our valve. The size of the diameter is the amount of electricity that comes out, right? So voltage, the first thing, it can be compared to the pressure of force. The higher the voltage, the more likely it is that it's going to cause an injury, just like the difference of force between high and low water pressure. So then when we talk about our amperage can be compared to the flow. The higher the amperage means a higher volume of electricity. In much the same way, a large diameter pipe will allow a greater flow of water than a smaller pipe. Okay, so pretty good picture here explaining that to us. And then the last would be resistance. And we could compare resistance to, restrictions in a water pipe. When the flow of electricity has resistance, this generates heat, which can cause results in fire, burns, or damaged equipment. Okay. So when we speak on electrical hazards, what do we think of, right? Contact with power lines. Always, we have our signs where, do not look up, or always look up before you climb. Are there any energized power lines? Call before you dig, 811. Some other electrical hazards would be contact with damaged electrical equipment. Take a look, think about, your workplace, even on, a little bit more on the personal side. Think about, at home. Do we have any extension cords, or do we have a favorite, surge protector that might have some exposed wires, some damaged electrical equipment? Maybe we have to wiggle it the right way for it to work. All right. If we have to do any of those are all signs that, hey, there's some electrical hazards associated here. We have some improper wiring. Maybe it's we're changing out the AC unit, or maybe something along those lines. We have water pump for an irrigation system, and we don't have time to go call the electrician, or everybody's booked. We need this done today. So we start tinkering, doing some improper wiring. Well, guess what? The likelihood of a fire or something go wrong really high at that point. Overloading. We have overloading of circuits or wiring. Let's think about this. Let's take a look. Is this something that maybe is similar to our house setup, or even in our cubes here? We might have more than a couple monitors. We might have a space heater. We might have a fan to cool us off when the space heater gets too hot. But do we have some overloaded circuits, right? Are we doing unsafe work practices, such as using a metal ladder against power lines, or wearing a lot of conductive material, jewelry when working around those electrical circuits and appliances? Okay, because think about the electrical injuries that are associated with those hazards, right? What could be the biggest thing we think about? The first thing, cardiac arrest, respiratory failure, because that electrical injury, that electrical current is passing through a portion of the body. Okay. What about muscle, nerve, and tissue destruction? Maybe we've all seen a picture of someone's fingers getting burned. I had a good buddy of mine. He used to run fiber optic lines for Comcast out of college, and they marked off the wire, or the wires is dead. No electrical power running through it. He cuts the wire, and 3 of his fingers were burned off at the tips, just from that intense electrical current running through those fingers there. Burns, thermal burns from contact with sources of electricity. We could even think really small. Think about maybe some of the aftermarket chargers we get, Amazon, dollar store. If they're plugged in for a lot amount of time and they're not good, or they don't have a good, conductor there, you put your hand or you rub up against it and you have that burn. So we see that at a smaller level on, our appliances, things like that. Secondary injuries, such as falling from a ladder after receiving an electrical shock. Okay, are we thinking about that? So how does these electrical shocks occur? So we have to contact with the electrical energy. A shock occurs when electrical energy contacts your body. Okay, that takes the body part of electrical pathway. Another way to get shocked is for you to become part of the path between a live wire and the ground. Electricity always takes the path of least resistance, and your body can become part of the path because it's a good electrical conductor. If you touch a live wire with your hand, electricity can travel through your body and exit through your foot. This kind of electrical shock is unfortunately very common. All right. So we become, a good conductor. Think about it. Our body is, 70% water. So, it takes the path of least resistance. Okay. And so when we think about that, maybe we've been shocked in the past of maybe painting the house, or maybe just something as simple as, static electricity. We're walking on the carpet, we touch maybe a metal object, we get that little bit of shock, right? So we're going to talk about the amount of current. First, the amount of electrical current or amperage. The more current, the more dangerous it is. Amperage is like the volume of water flowing through it. The greater the volume, the greater the hazard. When we talk about the duration, the length of time the current passes through the body, the longer the duration, the more dangerous it is, okay? And finally, we're going to talk about the pathway. The specific pathway the current takes through the body is the most dangerous when it travels through the chest, affecting the heart, lungs, or brain. Note that you cannot know the path the current might take through your body once it enters, but it may enter at one location and exit another. Excuse me, my allergies are through the roof right now and nose is running a little bit, but I apologize. So we're going to talk about the effects of electrical current on the body. And we're going to think about this. We got 0.5 to 3 milliamps. It's not even a full amp. It's a milliamp, okay? So we might feel a faint tingling sensation. 6 to 30 milliamps, we might feel that painful shock, severe muscle contractions, no muscle control. So we're slowly increasing. We're slowly increasing. We got 50 to 150 milliamps. It's extremely painful shock, respiratory arrest, severe muscle contractions, and death may occur. We think about this 1 to 4 amps. We have ventricular fibrillation, nerve damage, and death is very likely. Okay. You are likely to die from a shock of this magnitude. Okay. So that's 1 to 4 amps. 10 amps, you will experience cardiac arrest, severe burns, and probable death. Now, think about common everyday electrical equipment and appliances. For example, a 100-watt light bulb has 833 milliamps of electricity flowing through it. Okay. And think about this. This is a scary one. A typical kitchen toaster has more than 9 amps of current, which is certainly enough to kill you. So remember, the electrical equipment we use every day has enough current to cause serious injuries and death.
Yeah.
We think about it. The place I get the scared or the most scared is in the kitchen, or not the kitchen, the bathroom. Think about all the appliances in there. We got a blow dryer, a hair straightener. Um, you couple that with water, maybe some mist from the bath. So there's a lot of things that go wrong there. Also in the kitchen,
Natua.
yes.
Yeah, I want to just jump right in real quick because Brandy had a question about off-brand chargers and how sometimes they get hot or warm to the touch.
Yep.
And I was thinking about that too, especially like plugging them in in the bathroom. What do you think about that? Would you say
Yeah.
they're safe to use?
So that's the thing about it. Sometimes like the the wiring, the different types of solder they use there. It's really important that we have those GFCI, ground fault circuit interrupters that are there to, if there is like a lot of energy going through that interrupter will trip and cut off the energy there. So me personally, I wouldn't recommend the off-brand like the Temu, the really cheap 50-cent chargers from Amazon dollar store. I wouldn't recommend those just because of the amount of energy and the heat they transmit.
Okay. Also, I wanted to just, are you, you're still on the same first slide, just FYI.
Well, same first slide.
How does electricity work?
Oh wow. Okay.
So we need to advance just a
Oh,
bit, maybe.
okay, hold up.
Great question, Brandy. Really appreciate it. Yeah, I would say stay away. I agree with Natua. Like pay even $10 more for something that, especially with those Apple products, if you can get the ones directly from Apple, those are better for the life of your uh, phone or whatever it is you're charging anyway.
Wait, so Monica, I'm on the first slide.
You're on injuries from electrical shock.
Oh, now I'm on injuries from electrical shock.
Yeah.
Okay. So okay. Oops. Okay. Better now. It's still on injuries from electrical shock.
Yeah.
Okay, perfect. I apologize about that. So when we talk about injuries from electrical shock, obviously the first one there is electrocution. Electrocution simply means the shock is powerful enough to cause death. Handheld power tools typically carry more than enough current to cause electrocution. Injuries from electrical shock happen because electricity follows the path of least resistance, which in the body means your blood, organs, and tissue. Electrical current can damage nerves and body organs. Burns occur because the resistance of the skin and body as electric burns occur because of the resistance of the skin and the body as electricity flows through it. So really big injuries there. Our skin, our bodies are real good conductors, and secondary injuries occur when someone receives an electrical shock as a result of another type of incident. An example would be someone on a ladder with an electric drill who receives a shock, falls off the ladder. Another example would be someone working on a machine who gets a small shock that causes him to pull his hand or arm back quickly, striking a piece of metal and causing serious trauma to that hand or arm. So Think about that in your own personal lives. Have you had a secondary injury because of a shock? And it could be, something as simple as that, that electrical, the static electricity, right? Maybe we touch that object, we fling our arm back, it hits our funny bone, right? Think about how painful that small, tiny injury is. Hey, so that's an injury from electrical shock there on a small microscopic level, right? Um, did the screen advance? Okay.
Yes,
Um,
it did.
okay, cool. I just want to make sure because I guess I missed like 10 screens there, guys. So when we talk about the arc flash and arc blast, pretty scary stuff. But when we are on the news and we do see, electrical shocks in big factories, and you see that kind of like lightning bolt shoot out of a transformer or an electrical panel. Well, this is what they're talking about. Okay. So arc flash and arc blast are type of electrical accidents that are extremely dangerous. So that arc flash occurs when electricity travels through the air. This can happen when electrical devices such as circuit breakers and disconnects are open and closed, or a tool falls in there and touches that equipment. We're going to have that arc flash. An arc flash lasts only a fraction of a second, but check this out: the temperature it creates are up to 35,000 degrees, which is enough to vaporize metal. So even though we think, oh, it was only 1 second, 35,000 degrees for 1 second is enough to, melt that metal, vaporize the metal. Imagine what it'll do to your skin or your body. So pretty scary to say, needless to say. An arc flash causes severe skin burns. An arc flash can also travel. Consider it like a lightning bolt. Being in the path of the arc flash can cause traumatic injury. Therefore, always position yourself so that you're not in the pathway in the event of this arc flash. An arc blast is a pressure wave from that arc flash. It's essentially an electrical explosion that causes severe injuries and death, as well as major damage to facilities and the equipment. So really, really, really important there, to obey those laws. If we do see something locked out, tagged out, leave it alone. If it says warning, dangerous area, authorized personnel only. Hey, well, at the beginning of the class, we talked about, um, you know, who those authorized personnel are, right? Electricians. So when we talk about these electrical burns are very common serious injury related to electrical shocks. Electricity in the body generates heat because the body produces resistance. The heating of the body tissues results in electrical burns. Second degree and third degree burns can occur on the skin, or they may be internal, so that the person may not look seriously injured, right? Oh no, it's not a big deal. Where's your burn marks? No, it could be internal, okay? While electrical burns may look minor from the outside, they may have severe burns on the inside. They may cause damage to those internal organs and the tissues. Thermal burns can also occur from contacting surfaces that are extremely hot because of electricity, or when clothing or equipment catches fire. So that's that other thing we're talking about with those chargers. The other day, I got a speaker from one of the golf tournaments or whatever, and that's one of the common practices is use the charger that was provided with that piece of equipment. So got the charger, got the speaker, plugged it in to our island kitchen, left on there for a couple hours, and didn't really think anything of it. And I, put my arm down, and that little wire touching my skin, brought it back, and I said, "Dang, that thing is hot." So it was one of those things where, poor quality charger there. Think about it: if we left for the weekend and that charger kept getting hotter and hotter and hotter, what could potentially happen? Maybe there's a piece of paper there, hits combustion point, add that with some fresh oxygen. Now I have a kitchen fire. So really important to monitor those charging devices. So emergency response and first aid for electrical shock, because obviously electricity, there's some things that area might be energized. So the first thing we want to do is we do not want to touch. Okay. Do not touch the person if he or she is still being shocked. This is very important. The electrical charge could pass through to you. It's the same thing, just rule of thumb when we talk about, the AED. It's one of the other things, right? no one is touching the person when the AED is analyzing. Because the big thing with that AED is it's looking for an irregular heartbeat or no heartbeat at all. So if and the computers on those AEDs are pretty sensitive. So if you touch the person, the AED might be able to pick up that, the pulse there. So big one, do not touch the person when the AED is on. Do not touch the person as well. Shut off the electrical equipment that's causing the shock. If the shock is continuing, call for trained first aid personnel immediately. If you're appropriately trained, administer first aid and cardiopulmonary resuscitation or CPR as necessary. Okay, we don't want to touch that person. You could use something non-conductive, a piece of wood, to move that person away. But the big thing we have to do is turn off that electrical equipment causing the shock. Okay. Sorry about this page. It was cool transitions and like it dropped down. I thought I was doing a good job. Using an AED. This is a big deal. We talked about the AED might be able to shock the heart back into normal rhythm. Like I said, it's there making sure it's kind of like acting as your pacemaker, right? Your sinulateral node there. So it's going to be looking for those electrical synapses in the brain or in the heart. I apologize. An AED works by shocking the heart so it can restore that normal beating rhythm. AEDs can dramatically increase survival rate when used properly and in the first few minutes of when the person is suffering a cardiac arrest. So please, please, please. And like I said, many of the AEDs have a built-in system that talks through the instructions. So please, take a look at it. That's a shameless plug here. That's one of the trainings that we provide as a risk control team as first aid, CPR, and AED training. And it's one of those things that we have to practice, right? Practice makes perfect. Practice makes us be prepared in an event of an emergency because in those emergencies, we tend to forget little steps. We tend to, forget the obvious step. And when we're in a calm environment, we're like, oh, yeah, that's obvious. But in that emergency environment, electricity, your best friend's dying, someone we know is dying, the game changes a little bit. So we have to be prepared in that event. Big thing here, stay away from the power lines, stay away from those energy equipment, stay at least 10 feet away, keep equipment at least 10 feet away. We want to add 4 inches to 10-foot distance for every 10 kilovolts over 50 kilovolts. So an example would be, a power line that's 138 kilovolts. The minimum safe distance would be 13 feet instead of 10. So it just requires some math. But once again, call before you dig, call before you climb, all that good stuff. Don't dig any holes or trenches around the ground until you've confirmed there's no buried lines. That's the biggest one we have to do. Even if, at work, obviously, call before you dig. But the thing that we kind of tend to forget is when we're at home. Maybe putting up a post or a railroad tie or making a fence, things like that. We just think, oh, I'm going to dig down 3 feet or I'm going to get my auger and we're going to go down. Not a big deal. But guess what? Some of our tribes, some of our communities, we have underground utilities. They probably buried, have some energized equipment to, kind of preserve those lines. Call. A scary thing. It happened to us the other day with my little brother. He was out there digging a hole, and I said, "Hey, did you call before you dig? There's a bunch of lines coming through this area. We have to make sure because one hit with the shovel, one hit with the auger, probably get electrocuted. So please, please, please call before you dig." Okay. A big one here: report and don't use damaged equipment. Okay. Especially on the work site, on the job. We want to, make it a rule or make it a habit to, before every use, let's look at our tools. Let's look at our equipment to see if there's any damage, no cords. If it's, a last minute thing where, oh my gosh, this is the only cord in our event starts in 20 minutes. Well, the event starts in 20 minutes, but think about all the lives there, right? If someone dies, is that 20 minutes worth it? Probably not. So, take the time, go get a new cord that's not damaged, that doesn't have any fraying or sparks or smoke coming out of it. But, those are the things we have to look out for and take that extra precaution. Damaged tools may have exposed live electrical parts and wiring to a person. Report the damage to your supervisor. Electrical cords, which are easily damaged, exposing live wires, and that damaged equipment, we have to take that out of service. Okay. When we talk about any damaged electrical covers on electrical panels, junction boxes, and other equipment where live electrical parts and wiring may be exposed, please report that. Okay, we're not going to just put a tape or a blind eye to that situation. We're going to have to report it. You know, Personalize all your coworkers. How would you feel if one of them got electrocuted on something that you overlooked or said, it's not a big deal too, you know, because unfortunately that attitude, oh, it's not a big deal, that's not going to fly, especially while working on the job. And just another good rule of thumb and a good practice, electrical practice, safety practices, is ensure that the electrical equipment is grounded. Exposed cards can become energized, grounded or double insulated, on the tools. Take a look. I was just at Home Depot the other day, and anything that's electrical has that nice little double square there to show that it's double insulated. Is that something we looked for in the past when getting electrical equipment? But take a look. It's out there. It's advertised. If there's no safe path to the ground, exposed parts can become energized. The purpose of grounding is to provide a safe path for electricity to travel to the ground. If the grounding path is broken, for instance, by not having a ground prong on the plug, electricity will take the path of least resistance, which may be through your body. Electric power tools and equipment must be grounded or double insulated. Double insulated tools do not have to be grounded because they're designed not to have electrical hazards as long as their insulation has been not damaged. This kind of tool will be marked with the symbol with the square within a square, double insulated. Take a look. And so we talked about our ground fault circuit interrupter. This is what we're talking about. And take a look. You probably have this in your bathroom or outside of your house or where there's a lot of water in the area. A ground fault circuit interrupter provides excellent protection against the electrical shocks. The ground fault circuit interrupter detects the amount of current going to and flowing from equipment along the conductor or wires plugged in through the outlet. When the amount of current going to the equipment differs from the amount returning because of a malfunction, the ground circuit interrupter will trip and shut off the current before a serious shock can occur. The ground fault circuit interrupter trip at about 5 milliamps in a fraction of a second. It is still possible to receive a brief shock, but it trips so quickly that the shock won't be, harmful. If a ground fault circuit interrupter keeps tripping, a serious problem may exist. Don't assume that the circuit interrupter is defective and substitute a non-circuit interrupter outlet. Instead, have that qualified person come. Call the electrician and let them know what's happening. We just can't keep resetting it, flipping the circuit box, keep resetting it, flipping. That's not going to help. It's going to cause more damage. Those circuit interrupters need to be tested periodically. The test pushing should be pushed according to the manufacturer's instructions. Reset as well. That kind of happens after a rain, especially in New Mexico, because it's so dry all the time. We finally get moisture. That's circuit interrupter. Plug it into the outside, maybe around Christmas, things like that. Have to reset them. That happened to me. I moved into a house and I was outside and put up the Christmas lights and I'm turning on. Finally had to reset my circuit interrupter. Works perfectly now. And then when we talk about following the lockout tagout procedures, I know it's when we hear lockout tagout, to me you think of OSHA, but because we are tribes, we have our own sovereignty jurisdiction. I sometimes don't find that lockout tagout procedures are followed as rigorous as, let's say, the public sector here, in the United States, where you go to Amazon, you go to a Facebook, you go to a Walmart, you go to a Costco, and there's some dangerous equipment. It will be locked down. It will be tagged out. So it's just something that we could kind of promote and stress the importance of to our workers, to our tribal employees, that the lockout tagout procedures, they're an essential way to prevent serious electrical shock, right? these devices that prevent access to the hazardous entry, are known as lockout tagout. Lockout ensures that the equipment is not accidentally restarted by making sure that it's shut out, de-energized, and locked. There's actual physical lock on that piece of equipment or device. My big thing for that is we can't go around that lock, or we can't go around the tag just to say, oh, well, I know how to do it. Oh, that forklift that was locked out. Oh, well, the guy didn't know how to operate it. He's new. He wants to do everything by the book. If you just jiggle this key and, honk the horn twice, it turns on. No, we're not going to do that, right? Because anytime during that situation, something can happen, right? Something can malfunction. Maybe the brake doesn't stop. Maybe the gas keeps going, and we cause serious injury, or we can't shut it off. So please, 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 if something's locked out or tagged out, leave it alone. Okay. Tagout is used when lockout is not feasible and only if the tags provide protection that is equal to the protection of the lockout program. It involves placing warning tags on the equipment. Always follow the requirements of lockout tagout program and procedures in your workplace. So please, 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 maybe it'd be one thing in the handbook that, hey, we do have a lockout tagout program, but no one's using it or no one's following, the rules on this. So please just refresh yourself with your lockout tagout procedures, and no, if it's locked out, that doesn't mean, oh, we're going to find a way to MacGyver it. No, it's locked out for a reason. Leave it alone. Okay. So when we talk about the use of portable electrical equipment, before every use, inspect for damage. Okay, if there's any kind of damage, if it's not operating correctly, or if it's a little bit slower, starting to smoke, you have to click it on the side a couple of times. We are not going to use that piece of equipment. Okay. Check the cord and the ground. Maybe someone took out that ground plug, or the cord is starting to be damaged. Maybe you have to put some electrical tape over it, or start to smoke, or it gets really hot after 20 minutes. We are not going to use that piece of equipment. Okay. The other thing that we kind of tend to do is lift by the cord. Maybe we don't want to bend down, or we don't want to go all the way to the outlet. So we get the piece of equipment, yank it. We do not want to do that. Okay. So once again, make it a habit to go to the plug, go to the base, pull out. We're not going to just yank. Okay. Dry hands when plugging and unplugging. We might not think of it as often as we do, but just that one little drip, freak accidents happen. Just make it a habit of drying your hands. Finally, always plug the equipment into a ground fault circuit interrupter outlet. If the work area is wet or has moisture present, and when working on the construction site. All right. And then finally, we want to stay away from electrical work areas. Electrical work areas need to be isolated. There's some alerting techniques. We have safety signs and tags, barricades, and even in some places they have a safety guard. They have attendants to the lots. You see this a lot in the mountains, right? Where there's maybe a power plant going through, and there's these signs, there's warnings set up, 400 yards, 200 yards, 100 yards, saying danger, keep out, stay away, do not come into the area. So those are all there meant for us. It doesn't say, hey, let's go over there and see. It means, hey, stay away. This is some pretty dangerous stuff. There's some pretty powerful equipment. Stay away from this area. Okay. And then some key things to remember. Exposure to electricity can be dangerous. We want to watch for electrical hazards. We want to know of those electrical hazards. My big thing too is the space heaters in the office. I'm not a big fan of the space heaters in the office. Get a little bit freaked out. But if we do have the space heater in the office or in a cube, let's make it a habit. When we are going to leave the area, let's unplug that piece of equipment. Because how many times has this happened? We have our space heater on. It's cold in the morning. We leave our office or our cube, and we have every intention of coming back. Oh, I'll be back in 10 minutes. But now, life happens. we leave for 10 minutes, we get a call from maybe our kid or mother or something, we have to go handle that situation. Now that 10 minutes turns into 2 hours. But we end up saying, well, I have my laptop, I'm gonna work from home. No one there in your office knows that, hey, we had that space heater on. Maybe we took out the plug or the ground, or we moved it to a way where it doesn't have a on off setting where if it gets too hot, it shuts off. Now the space heater is on for 8 hours, 12 hours, 10 hours. What is mostly in our cube? Flammable, combustible materials, right? Paper. Maybe we have some cleaning solvent that we shouldn't be there. And guess what? It gets too hot. Now we have a fire in our cube. So let's just make it a habit to unplug that space heater. They emit a lot of energy. Maybe I have a little soft spot in my heart for that, just because it did happen. I some socks caught on fire in my dorm room from a space heater. So please, 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 be really aware of those hazards. Be really aware how powerful this electricity is. You have appliances that we use every day that could kill us, right? Um, the toaster, the blow dryer, the iron, the straightener. Okay, and ultimately, we have to seek assistance from a qualified person. Okay, if we're stressed, or if we're stressed for time, or we're pressed for time and we have to do this, we have to MacGyver our electrical system or our AC units or whatever. We cannot do that. We have to seek that qualified opinion, that electrician's expertise. It happens. Just the other day, there was a fire in our community, electrical fire. Is the cause from a faulty piece of equipment, or is it from the person who's not an electrician wiring the house? So what is the problem there? Probably the person wiring the house, right? Because you're not an electrician. So just some things to remember. Take a note, on our safety programs or your jobs or your tribes or your housing authority electrical safety program. Are there some best practices? I know Monica uh, supplied a couple of tip sheets for homeowners, things to do at the home. We could also take those practices into the workplace. We could also establish some electrical safety programs. And that's all I have on my end. I'll stop sharing my screen so I could see some questions. If we have any questions, comments, feel free to share. um, and I apologize about kind of how choppy this PowerPoint was today. I thought I was going to be cool and have transitions and things, but it ended up backfiring a little bit.
I think we're having all kinds of technical problems today because it says my camera's on, but I'm not showing up. Can you hear me though?
Yes.
No. Okay. Well, thank you so much for that great presentation. And I put a link to Google Drive of materials, but I'm also going to send it out in an email afterwards, like I do every time. Um, uh, Not to what advice do you have for someone who maybe their partner has really high self-esteem about that they can do anything and therefore that includes fixing things electrically, stuff like that. What's the best way to approach something like that?
Well, if it only takes one time to get shocked to, laugh at it and say, "Hey, electrician, come over here and do it," but it's the ego is a big thing, but honestly, at the end of the day, when in doubt, anytime you have to watch your YouTube video 3 or 4 times, that should be the number one red flag, saying, "Hey, I need to get the electrician
Yeah.
here. I need to get that electrician here." And the other thing with that is we have to get the right electrician for the job. Not every electrical hazard is the same. You might need a little bit more expertise. You might need a little bit more, specific to that problem. You wouldn't want to get the first year electrician out there, to work on a 480 volt 3-phase system. You would have to have a little bit more experienced electrician. So with that, going the cheapest route, if you do want to get the electrician, might not always be necessarily the right thing as well, you know.
Mhm.
So yeah,
Definitely. Want to check their references for sure.
yeah,
Um, and if their house burnt down in the past, then they're not the electrician for you.
yep. No,
Um,
it's getting pretty crazy now, you know, with the amount of electrical work, especially if you have like a solar system, solar energy system that has to get, you know, linked into your house, you know. So and then say you want a charger for your electrical vehicle, right? Um, all of those things, as electricity is becoming more and more um, into our integrated into our lives. You know, every single
Absolutely.
day we do something with electricity. You know, flip the switch, and that's the other thing too. If we do start to like hear weird noises in when we're flipping the switches on our for our lights, or maybe there's a pop, or we plug in our laptop into the wall and it starts to smoke, please let's get that referred right away. You know, especially on the job, especially at work. You know, you probably even more so at the home, but you know, when we're at work, let's get that. Let's get the call. Let's get the call into maintenance or you know the proper channels there.
I always think about if you plug in a lamp and it smells funny, that is not the lamp for you. That
Yeah,
is a unplug and move on.
yeah,
I have to agree with you. I have strong feelings about space heaters at work, but mostly because um, it's usually in the summer. Someone's got a space heater because it's so cold in the building and the temperature wars are going on. I say put some socks on, you'll be okay.
yeah. No, put the socks on. You'll be all right. Take a walk and get that blood flowing. There's a whole lot of ways we could heat that temperature up, as opposed to like putting in that space heater. And like I said, it happened to me. Um, I lived right there in the garage, and one day in Cruces it got finally cold, you know, and I had to put that space heater up and left for my final. Come back and my socks were smoking.
Oh,
I couldn't believe it. I couldn't believe it. I could have burned down the house, but
all right.
you know,
Well, thank you everyone for thanks for Christopher. Christopher says, nice presentation, great explanation of the right guy for the right job. All the low voltage systems and high voltage connections. So thank you, Natsuwa, so much. And next month we are going to have an update on the Indian Housing Block Grants. I will send a link about that, and as well as an email and this presentation. Not so maybe we'll get the transitions cleaned up a little bit and we'll make it
yeah,
into a PowerPoint. How's
yeah,
that sound?
yeah, we could do that.
And then, Wilfred wants to know how often you should replace all your outlets, light switches, and appliances.
Um, I would say about like 15, 20 years. And that's one of the things that we're seeing now, especially like IHBG homes that were kind of built in that first phase in the 70s. We're kind of seeing them slowly starting to get, you know, replaced. But, you know, 70, 2025, that's a little bit overdue. But that's the year they got NFPA, about 15 to 20, 25 years. So gives you a
All
little
right.
bit of range there. But yeah, that's what we're seeing. We're seeing a lot higher claims in those homes that are kind of a little bit older, 1970s. A lot with electrical and like flood with pipes bursting, things like that. So
Mhm.
that's kind of sitting in that 15-25 year range right now.
Well, thank you everyone for participating today. And like I said, I will send an email out later today with links and good information. And we'll see you next month. Thanks, Natwa.
Perfect. Thank you. Have a good day.